This is 3.7, solving systems of equations using Cramer's rule. All right, so before we start getting into solving systems using Cramer's rule, first I need to teach you how to find the determinant of a 2 by 2 and a 3 by 3 matrix C. All right, so for a 2 by 2 matrix C like number 1, what you're going to do is you're going to multiply the diagonal. So 1 times 7 will give you 7. And then you're going to multiply the other diagonal to get 6, and then you subtract. So the final answer for that determinant is 1. All right, let me show you again with number 2. So first, you're going to multiply this diagonal, and yes, the order matters since we are subtracting. So we're going to multiply 1 times 6, which is 6, and subtract that with the product of the second diagonal, which is -5, giving you a final answer determinant of 11. All right, why don't you give that a try with number 3? So pause the video, and once you have your answer, go ahead and unpause, and I'll show you the answer. All right, so the answer for number 3 would be, if you multiplied 2 and 4, you would get 8. Subtract it with the product of 2 and -1, which is -2, giving you a final determinant answer of 10. All right, let's go ahead and try it now with our 3 by 3. Now the 3 by 3 is a bit tougher. So to help us out, what we're going to do is your first step is to rewrite the first 2 columns next to the matrix C. So for example, number 4, I would write 6, 5, 1 for the first column, and -1, 2, and 3 for the second column. All right, and then now we're going to multiply our diagonals. So the first diagonal I'm going to multiply is going to be the 6, 2, and -2. So that gets me a product of -24. Then I'm going to multiply the second one right next to it of -1, -1, and 1. And now I'm going to add that to my -24. And I'm going to do that again. I'm going to multiply the 1, 5, and 3, which gets me 15. I'm going to add that to the rest. All right, so putting that all together, adding those 3 numbers, I get -8. Now that's not my final answer, because now I have to go in the other direction. So I'm going to multiply the 1, 2, and 1. That gets me 2. Multiply the 3, -1, and 6 to get me -18. And the last one I have is -2, 5, and -1. So that gets me 10. Okay, adding all those up, I get -6. So to get your final determinant, you're going to subtract those 2. You're going to take your first number, subtract it with the second number to get your final answer. And in this case, it is -2. All right, let me show you one more time, and then I'll have you try one on your own. Okay, so for number 5, once again, I'm going to copy down the first 2 columns right next to the matrix. Then I'm going to take the first diagonal, multiply, and I'm going to add that with my second diagonal of -1, 5, and 2 to get -10. I'm going to add that to my last one 6, 3, and 3, which gets me 54. Adding those all up, I get 48. Okay, let's try it going the other way. So I have 2, 2, 6, so that gets me 24. I'm going to add that with the 2, 5, and 3, giving me 30. And add that with the product of 1, 3, and negative 1, which gets me negative 3. All right, so adding those all up together, I get 51. Okay, so my final answer, I'm going to take my first number of 48 and subtract it with my second number of 51, giving me a final answer of negative 3. All right, why don't you try it with number 6? Go ahead and pause the video, and once you're ready for the answer, go ahead and unpause. All right, so your final answer for number 6 should be 40. Okay, hopefully you got that. If not, go back and just check for careless mistakes. It's very easy, especially with the 0. Just make sure that when you multiply by 0, you are getting 0. Okay, so all of that was to prepare us to get to solving systems of equations using Cramer's rule. All right, so basically you are going to be using these determinants to solve for your x and your y. All right, so the first thing you're going to do is you are going to find the coefficient matrix. And you literally are going to make a matrix. I'll write that, coefficient matrix. And the coefficient matrix, we're going to call that C, is going to be the matrix of all the coefficients. So the 6, 6, 4, and negative 4. And we're going to find the determinant of that. So we're going to take the first diagonal and subtract it by the product of the second diagonal. All right, so that would be negative 24 minus 24 to get you negative 48. Okay, now we're going to go ahead and solve for x and y using that. So what you're going to do is that you're going to solve for x by having another 2 by 2, and the 2 by 2 inside, what you're going to do is, because you're solving for the x variable, you're going to replace the coefficients of x with the constant numbers. So instead of 6, 4, I'm going to write 9, negative 42, and the y coefficients stay the same. All right, and we're going to divide that with the negative 48 we got for the determinant of the coefficient matrix. Okay, so find the determinant. So we have 9 times negative 4, which is negative 36, minus the product of negative 42 and 6, which is 252, if I'm not mistaken. And I'm going to divide that by the negative 48. All right. And so that simplifies down to 216 over negative 48, which gets me negative 9 over 2 for my x. All right, let me show you one more time with the y, and I'll have you try with number 9. All right, so for the y, once again, I'm going to replace the y coefficients with the 9 and negative 42. but I'm going to keep my x. So you replace the coefficients of the variable you're trying to find. I'm going to divide that by the negative 48. All right. So we're going to multiply, and we get 6 times negative 42 was the negative 252. And I'm going to subtract it with the product of the other diagonal, minus 36. Okay, so I get negative 288 over negative 48, and that turns out to be 6. Okay, so that is your final answer. We have x is negative 9 over 2, and y is 6. Okay, so why don't you give number 9 a try, and once you are ready, unpause the video to see your answer. All right, so for the answer for number 9, I wanted to explain it since this is a little bit tricky. So the first thing you would want to do is to get both equations into standard form. So I moved everything around until I got it into standard form right here. All right, then after I did that, I found my coefficient matrix and I found the determinant of that. And that's where I got this negative 16. All right, so the coefficient matrix was 5, negative 3, 3, and negative 5. Find the determinant, and that's where I got the negative 16. All right, then to find x, I replaced the coefficient of x with the 6 and negative 4 constants, kept my y coefficients, found a determinant, and divided by the negative 16, and I got 12. And for the y, I replaced the coefficients of y with the 6 and negative 54, found a determinant, divided by negative 16, and then I got 8. So my final answer here I got was 12, 18. Okay, all right, that is it for this half of the lesson. We'll finish off this lesson another time.